Okay, I'll close this. Okay, so article, I think, have you gone through this article of, this was the reference article. Risk factor associated with diabetic retinopathy in patients with diabetes mellitus type 2. Okay, so here, I'll come to this article. Let me first explain few basic things regarding the ordinal logistic regression. So ordinal logistic regression. So here we have seen yesterday also that if a variable is polytomous, what do we mean by polytomous? If it has got more than two levels, means 3, 4, 5, whatever. What is a binomial dependent variable? If the variable has got two levels, then we call it as a binomial, as we have seen in the surgery cancellation. And multinomial, what we have seen yesterday, when there was no relationship, means like there's no ordinal nature, then it is multinomial. Again, ordinal nature, you can also treat it as a multinomial. So you will see that that's why this ordinal logistic regression, this option is also there. Like when you want to treat your polytomous variable as ordinal, then you have to go for this ordinal logistic regression. When you want to treat your polytomous variable as multinomial, then you have to use a multinomial logistic regression. The with the multinomial, as we have seen, it gives you the n-1 or k-1 model. That means if there are three levels, it will give you two models, the way we have discussed yesterday. But in case of proportional odds, it only gives you one model. But again, in case of a multinomial, was there any assumption which you guys seen? Was there any section of assumption testing in case of this thing, multinomial? So in multinomial, generally, that general thing which you know regarding, otherwise there is no assumption check in case of a Jamovi. And otherwise also, if you see assumption option, it is not there in case of a multinomial. But for proportional odds, definitely, except for multinomial, of course, assumption is that the dependent variable should be polytomous and it should have more than two levels. And the other things like the independent variable should be it can be continuous, it can be categorical. In this case, it is a ordinal. We treat the dependent variable as ordinal. Now, what can you see in this slide? So we will start this with a simple mathematics. Now, if I need to maintain the same amount of difference at each level, how will I do it? So this is, if you see, this is a female and this is a male, right? And reference level is female and this is male. So this is the 0. That means it is the odds or number. Let's say I'm not calling it as odds also. So 0 and 2 is there. And if I want to maintain the same difference at all level, how will I do? So this is 0 and 2. This is 1.5 and 3.5. If it is 1.5, what value will here? It will be 3.5. Again, if it is 3.5, what value will be here? Yes, all of you please type. I want to, yeah, very right. At level 3, 5.8. Yes, and at level 4, 6.4. Right, true. So what I am doing, what is this actually? These levels are basically the levels of the dependent variable. These levels are the dependent variable. So now, but this is if you want to maintain the same difference. Now, if I want to maintain the same ratio at all levels, then how will I do? So this is my reference. This is level 1, this is level 2, this is level 3, and this is level 4. So the ratio at this reference level is 1:2. So what will I write here at level 1 if I want to maintain the same ratio? 3. Dr. Prashant is right. 3. At level 2, it is 7. True. At level 3, yeah, you can multiply. It's 7.6. True. And it is 8.8. So the ratio will be same. If you see, so these odds are different. Odds are different, but the ratio is same. So similarly, consider a hypothetical study if I want to see the effect of gender on the various levels of anxiety. So I have this anxiety is my dependent variable, and I have classified this. There are various levels of anxiety. So there is a mild anxiety, there is a minimal anxiety, mild anxiety, moderate, severe, and extremely severe. If these are the 5 levels of the anxiety, it is a polytomous variable since it has got more than 2 levels. And again, it is a ordinal because there is an increasing nature. The minimal is the least and the extreme is the most. So how, if you see this, the minimal has got this, this is again, this is male and this is female. So in these two category, if I see the ratio, odds ratio, if I, this is my reference. So the odds ratio is 1.2 because 1.2 by 1. So this is the odds. What is the odds ratio? If you have to calculate the odds ratio of this 2.6 by 2.2, what will be the value? Yes, all of you please calculate, then only we will understand. So these are the odds. So if you see the initial odds ratio is 1.2. The odds ratio is here, it is 1.2. And then this is, again, if you do like 2.6 by 2.2, it will be nearly same, 1.2, 3.7 and 3.1. So what you have to do, you have to do like 3.7 divided by 3.1. So that's how you have to do. And then 4.2 by 3.5. I think, yes, 1.18, roughly it will be, let me do this. Yes, so I am doing 2.6 divided by 2.2. So what is the value? It is 1.18, nearly 1.2. Again, 3.7 divided by 3.1. It is again 1.19 in this here, this 3.1. The fourth case, 4.2 by 3.5. So 4.2 divided by 3.5. It is again 1.2. And the last one is the 5.5 by 4.6. So 5.5 divided by 4.6. So it is again 1.19. So you can see that we are maintaining this odds ratio at all levels. So can we say that the effect of gender on various level of anxiety is same? Because with increasing levels, every time the odds ratio was maintained at neither of the any level, it was not like the female has got less or male has got more. So if you see this, in all the cases, the odds of the anxiety was more in male as compared to the female. So can we say that the gender has it has got the same effect on all the levels of anxiety? So now you consider this new the other one. This is the previous case. This one, the uh, table which you can see up here. This one. And this is your new table. So if you consider this new result in comparison to previous, and then we will see the odds ratio. So in the first case, the odds ratio is 1.2. What is the case? So I will calculate this. This is 2.5 and 2.2. So 2.5 divided by 2.2. So value is 1.13. So it is less, like again, it is very near to 1.2. Again, 3.5 divided by 3.1. So it is 1.12. So it is like 1.2, very near to 1.2. Again, 3.9 by 3.5. 3.9 divided by 3.5. So it is again 1.1. And if you see the last one, it is also the 1.1. So in this case, what you can see in this example, that odds again, it is changing, but the ratio is almost same. It's 1.1. So that's why we have used this term nearly same. In the previous one, it was
Same.
exactly same. Here it is nearly same because 1.1 and 1.2. So we can say that the effect of gender on various level of anxiety is nearly same. Now consider this third example. So what is this? If you calculate the odds ratio, it is changing in all these categories. So if now again I calculate it, it is initial, it is 1.2. If you see the other category, which is 3.4 divided by 2.2. So what is the value? Value is 1.54. So it has increased from 1.2 to 1.54. Again 1.8 and 3 point. So 1.8 divided by 3.1. So you can see the odds ratio is now 0.58. So instead, it has decreased less than 1. If you see any other category, let's say the last one, 8.2 by 4.6. So how we are doing it? 8.2 and divided by 4.6. It will be like 4.6. So it is 1.78. Again, very large than the 1.2. So in this case, what you see that the odds ratio is not same in all the levels, like all levels of minimal, mild, moderate. So what we can say that the effect of gender on various level of anxiety is neither the same nor nearly same, because it's totally different. At one place it is less than 1, at one level it is more than 1. So that's why we can say that the gender has not the same effect at every level. That means that the gender has got a different effect at different levels of anxiety. What do I mean by that? Like if you see the previous one, this one, you can say, like in case of a minimal anxiety, if there is a minimal anxiety, then male has got higher odds of suffering from minimal anxiety. But if you see this moderate anxiety, then you can say that the female was having higher odds of suffering from moderate anxiety. Similar is with the severe anxiety, that the females have the higher odds of suffering from severe anxiety. But again, this got reversed here because now the odds is more in the male. So what can you say? That at various levels of anxiety, gender has got a effect. It is not the same because that constant is, it was not maintained. At one level, the male are more, odds are more in male, and in another, odds are more in female. Am I trying, am I making myself clear to you? Am I making some sense to all of you? What I want to explain with this? Okay. So this is just why, because this dependent variable. So here what we are seeing, that the dependent variable here is the all these ordinal nature of anxiety, and the independent predictor is the gender, right? So that's how you can see that in the previous two example, the odds was nearly maintained. Every time the male was having the higher odds in all the category of anxiety, right? But here you can see that it is varying. In moderate and severe, the odds are more in female, and in minimal, mild, and extreme anxiety, odds are more in males, right? So now what to do? So this we have seen. So yesterday we have seen this slide, and you guys have also commented regarding which are the variables which has got a natural ordinal nature, and which are the variable which has got a normal multinomial or the nominal nature. So we have seen that pain, and you guys have only told me that pain and vaccination and tumor grade, that was normal ordinal, and the other two, like the choice of conception and the preferred method of follow-up and preferred teaching method, that was a multinomial, right? So we have discussed that if a variable has got polytomous, more than one level, two levels, then we call it as a polytomous. If a variable dependent variable is polytomous, you have got two choices. You can either perform a multinomial if you want to, if you don't want a ordered nature of the variable, or if the variable, the natural nature of the variable is ordinal, then you will opt for a ordinal logistic regression. So now the problem is whether ordinal nature, you see that whether you have to go with the ordinal nature of the variable, or you want to treat the ordinal variable also as a multinomial variable. So by seeing all these term, I think I hope all of you know what is a multinomial, what is a ordinal by this time. Yes, it is for all the people who are like beginner, maybe. Okay, so SV is writing, but ma'am, that could be true for multinomial. What, Dr. SV, can you please elaborate on this? That could be true means which could be true for multinomial? That odds thing, it is maintained at every level that you want to see. I didn't get. Means odds could be different. See, in multinomial, it treats, that's why it gives you two different model. Because it takes it that proportional odds. This, why we have shown this through this, we want to make you understand the concept of proportional odds. At each level, the odds ratio was constant. So this was the concept of proportional odds, which is one assumption if you want to perform this ordinal logistic regression. In case of a multinomial, it gives you two model. In case of a proportional, it will not give you two model. It will give you only one odds ratio. Can you recall multinomial? I will again show you today the difference between multinomial and this ordinal. There is a difference. Why? Because the number of model, how it treats the variable, there's a difference. So I will perform on the data set, on the same data set, the ordinal also and the multinomial also. Because yesterday also we have seen that the levels of that robustness, you can also treat that as an ordinal outcome, but we treated that as a multinomial, right? So today also we'll see if this assumption of proportional odds is not met. If that is not met, you cannot perform ordinal. Then again you have to go for multinomial. Are you getting my point? If this proportional odds, if the it is different, if the odds are different at each level, you cannot go for proportional odds, because that's the most essential assumption of a ordinal logistic regression. If the assumption of proportional odds is not met, then even if the nature of your dependent variable is ordinal, you have to go for multinomial, right? That's why you will see that proportional odds is not very commonly done, ordinal logistic regression, because this assumption doesn't always get fulfilled, and that's why then people go for multinomial. Yes, yes, we will do that. We have to check the assumption for each independent variable. And those independent variable which fulfills this, like right now we have just shown with gender, but we'll check that with gender, with comorbidity status, with everything. And those variable which are filling this assumption, we can take only those variable in the model, right? So that's the most important criteria rather, or assumption for running a proportional odds regression or ordinal regression.
Ma'am, I have a small doubt, ma'am. So, like you showed in the last example of the anxiety, where you have the different odds, like those varying, right? This example exactly, ma'am. So here you cannot do the proportional odds, so you have to choose a multinomial.
Yeah.
Do it here.
Yeah. We can't do ordinal.
Okay. Okay. Thank you.
We will come actually when I will do in the data set, then it will become more clear to you. Because right now I'm just telling you a little background theory. But once you actually see in the data set, then it's easy for you to decide. Okay, Dr. Arun, your hands are raised. Do you want to ask something? Okay, maybe the previous hand.
Yes, ma'am.
Okay.
Yes, ma'am. Ma'am, my question was, uh, what are we that trying to achieve, ma'am, by doing this ordinal logistic regression? Uh, I mean, w- valid logistic regression or multinomial was as good. Uh, what is the need of specifically doing this ordinal logistic regression?
So you just wait for, I think, let's say half an hour. And you
Okay,
just see, and then probably you will get answer automatically.
and
Because
ma'am, conditional logistic regression is different from this one.
yes, it is entirely different. The data is arranged differently in case of a conditional logistic regression. Conditional logistic regression generally we perform in case of a mixed, matched studies. So there
Okay,
you enter the data in a group. We'll show that also, not today, but probably on Monday. There is a
thank you,
session
ma'am.
on conditional logistic also.
Thank you, ma'am.
So you will get your answer. I don't need to tell you. You will automatically understand why there is a need to do this ordinal, or why not multinomial, or why multinomial, and all these why answer you will get. Okay, just for half. If you see the data and if you see the output, now you yourself will comment. Wait for half an hour. So what is it? So temptation is like if the number of categories of ordinal data is 3 to 5, then again the way we have shown you, you can merge these categories and run a binomial logistic regression. But we learned that leads to the loss of data. So you can again make a one category of mild to moderate, the other category as severe, or one category as mild and the other category as moderate to severe. But can you do this mild and severe and moderate as second category? Can you do like this in case of ordinal nature? Is this third category? Are you convinced with this third category? Yes. Can you show? Yes. Arifunera is writing no. Yes. We cannot do this. Why? Because this is not preserving. See, so that's why it is not treating. So if you do something like this, then the ordinal nature is not maintained. So like in case of a ordinal, the data, any arbitrary reference category is not possible. Okay. But what was there in multinomial? Can you do this if you treat this variable as a can you do that in multinomial? So in multinomial, there is no order. Like you can treat, because variables, you don't consider those variables as in a hierarchical nature or in ascending or descending order. So that's why if the third category is not possible. So that's why that is not successful, that merging the category. Now the other temptation could be, you can again, if the number of categories of this ordinal data, again we have discussed that you can consider this as a multinomial and you can perform a multinomial logistic regression like Dr. Arun was saying. What is the need of this ordinal if the multinomial is giving the result? Then again, we are just telling you the option that we take the reference category as mild, then odds will be calculated for moderate and severe. The way we have seen the multinomial, it is the same repetition. If you take the reference category moderate, then odds will be calculated for mild and severe. So just by changing the category, the way we have seen yesterday, you can change any category. You can compare pre-frail, frail, taking the robust, or reference category according to you. So again, you give your result. The third is this thing is you can treat this ordinal. If there are like 7 or 8 levels. You can, because we know that if the levels of ordinal is more than 5, 5 or more than 5, you can treat it as a continuous data. And then you can run a linear regression also, because in linear regression, what happens? The dependent variable is the continuous in nature. So ordinal variable having 5 or more, you can treat it as a continuous also. And you will see many papers where they have treated this continuous and they have run a linear regression. So you can do that. That is also one. We are just telling you what are the various options you have if you have got a dependent variable as a ordinal. But again, this is the same. If I ask this question, which of the following reference is not suitable for ordinal outcome? So like in first case, minimal depression versus others, minimal mild versus moderate severe, severe versus other, mild versus other, and moderate versus other. So which one is not possible in this case? Yes. E. True. All of you agree? E is not possible? Okay. So now this was the options with the this ordinal nature of variable. Now we will see the question. So let me show the article first. This was the article. So here they want to predict the risk factor associated with the diabetic retinopathy. So are you guys okay? Do you want a 5 minutes break or shall we continue? Because since it's past 1.5 hour. Yeah, it started at 10. So do you guys want 5 minute break before
Yes,
we
ma'am.
start? Okay.
10:35, 11:35, 11:40.
Okay. I'm sorry, I forgot actually. Then I just saw the time.
11:40.
11. So I was discussing this article, this risk factor associated with. Yeah, we are starting the session. Are we all back? Okay. So this was a short report on the risk factor associated with diabetic retinopathy in patients with type 2 diabetes mellitus. And if you see the article, they have performed, if you see the finding, just reading the abstract, that they have performed this on 120 patients, and they have univariate and multivariate analysis. Multivariate ordinal logistic regression was performed at the, if you see, and they have seen that positive association between the diabetes retinopathic severity and age. And they have also seen like other, this thing, HB1AC level. And all these factors except for age retain their statistical significance at the multivariate ordinal logistic regression. So age was not there in the final predictor, but all other variables were there. And this was their table. And this was the table for the ordinal logistic regression. So if you see here, what can you see? There is one, or I'll go to our result also, but if you see, there's only one model here. So there's one table where at the various levels, because ordinal logistic regression, the way we have seen, at each level that odds is maintained, proportional odds. That's the basic assumption of this ordinal logistic regression. That's why if that assumption is met, it will give you one model. It will not give you many model. Like if you perform a multinomial logistic regression on this data, it will give you k-1 model. That means there are 5 levels here. If you just read this, the diabetic retinopathy, they have defined 5 levels. I'll just show. So these are the levels, like retinopathy stage, there is without finding, mild, moderate, non-proliferative, severe non-proliferative, and proliferative. So how many levels are there? 1, 2, 3, 4, 5. So there are 5 levels. If you perform a multinomial, how many models it will give you? Yes, Please write in the chat box. 4. Because it will give you odds ratio. It will, yes, all of you are right. It will take 1 as a reference, whatever you suggest. Like, let's say, if without finding, if you select it as a 1, we'll see that as a reference, then it will give you the odds of mild versus none, moderate versus none, severe versus none, and proliferative versus none. Am I right? It will give you 4 models and 4 odds ratio. Okay. But what can you see here? How many odds are there in this table? If you see the gender, hypertension, years of diagnosis of DM, HB1AC, how many odds ratio are there? Or what number of model? How many model? Which the author has given. Have they given many? Yes, all of you please write in the chat box. Dr. Arun, probably because this was your question also.
Not
Yes.
four models, ma'am.
No, Dr.
Right
Arun.
now.
It is giving only 1 model. If there has been 4
Yes, ma'am.
models, then 4
Yes, ma'am.
odds ratio of gender only. Then in
Yes,
that
ma'am.
case, you would have like 4 odds ratio for this hypertension, 4 for
Ji,
this
ma'am.
diagnosis,
Yes, ma'am.
and 4 for HB1AC.
Now,
Because,
yes, ma'am.
but here what you see, there's only 1 model and it gives you only 1
Yes,
odds.
ma'am. Yes, ma'am. Yes, ma'am. Yes,
So what do we mean by this? This means that the gender has got that odds ratio was maintained across each level. And there was, even if there was an increase in odds, the ratio was maintained. The same which we have seen in those slides, where there was an increasing odds, but that ratio was maintained. And there was one case when the ratio was not obtained, means maintained. So in this case, uh, giving 1 odds ratio means that the gender, what do I mean by this male versus female? And this takes as a higher category. Means if I have to, it is writing that category or increment. Can you see this? Increment means it will always take the lower category as a reference. Means this odds ratio of 3.57 in male versus female, means female is reference here. In male, it was more. Odds of having the higher odds of the category means it club the category. Category means it clubs the, let me come here. How it makes, like, without finding and all these 4 club together. That's why we call it as a cumulative odds. Then these 2 clubbed in 1 and the other 3 clubbed in 1. So then this will be another. Then these 3 clubbed together and these 2 clubbed together. So, like, going into the higher odds, this is just telling you at each level, that means in proliferative, this thing moderate, in severe also, this odds ratio is maintained across each level. And since that proportional odds assumption was maintained, so that's why there is no need to give 4 models, because at every level there's only single odds ratio, which is like telling the odds of the higher category. Means the odds of higher category means odds of proliferative, moderate versus none, then odds of the severe versus none. So severe means none, means it actually accumulates, it club these category. So that's why it is also like you can say that this is the concept of proportional odds. I will show this in the data also, how to do that. So this was the paper. You can go through this. Now I'll go to the question.
Ma'am,
Yeah.
I have a question. How could I know that there the odds ratio proportion is maintained in this paper?
You can see that in the assumption. If the maintained means I didn't get in this paper. If the author has reported that, that means you have to accept. They have written in the above this thing. They have written that they have checked for this. There is a statistical assumption of testing this odds, and if that assumption is met, that means it is nearly same at all levels. So that means proportional odds assumption is met. That means only single odds ratio is there. So you have to go by the author, this thing. They will not give you 4, but I will show you here. I will show you in the data set. Sumana, I don't know whether I am making myself clear or not to you.
Yes, ma'am. Yes, ma'am.
Okay. Now we'll see the question. So this is just the background that diabetic retinopathy is one of the most common microvascular complications of diabetes and a leading cause of preventable blindness. The condition progresses through distinct stages from no retinopathy to the proliferative retinopathy, each representing an increasing severity of vascular damage. And then several risk factors like poor glycemic control, long duration of diabetes, hypertension, demographic variable like age and gender, they have been associated with the diabetic retinopathy development. So in this exercise, what we are going to do? So my objective is to identify the factors independently associated with the severity of diabetic retinopathy. And what are my dependent variable? My dependent variable is the severity of diabetes retinopathy, and all there are 5 levels which we have seen just now, and these are my independent variable: gender, age, years of diagnosis. It's in the form of a ordinal, so I have categorized it like 0 to 5 year, 5 to 10, 10 to 15. That's how the author has done. HB1AC level is also like a ordinal, like less than 7%. The category 2 is 7 to 8.5%. Category 3 is more than 8.5%. And hypertension is binary, yes and no. Okay, so I will go to the data set. So let me delete this. Now this is my data set. I see the data and the variables, you can see the male and female. Their female is 0 and male is 1. If you see the age is continuous. This diabetes duration again 0 to 5 is labeled as 0, 5 to 10 as 1, 10 to 15 as 2, and 15 to 20 as 3, and 20 to 25 as 4. It is category. Again, less than 7%. This HB1AC is also, and more than 8.5%. 3 levels are there. Then again, hypertension like no and yes. This diabetes severity has got 5. No diabetic retinopathy, mild, moderate, severe, and proliferative. 0, 1, 2, 3, 4. So this is the data set. Now, one of the most important assumption which we have read, that is the assumption of checking the assumption of what? Proportional odds. So in previously what we used to do, that we used to tell this assumption in SPSS, because in GEMO this assumption check they have not still put in this module. Assumption check of there is a we call it as a test of parallel lines. So test of parallel line is not there. So there are 2 ways of checking this assumption. One is to create variable. Okay. So I'll create variable and I'll show the various odds ratio. I will perform those many binomial logistic regression. So how I will do that? So what I'm doing now, I have shown you the data set, right? Now I will club the variable, because how we do it generally, we club the cumulative categories. So how I will do it? So whatever I am showing you now, it's for checking the assumption. I have not still started the ordinal regression. So this is my hypertension. It is in the ordinal. So now what I'll do, I will transform this variable. So there is an option of transform. I will use create a new transform. So it is already there. So we have used this transform category. So let me tell you. So you know about this code now, 0, 1, 2, 3, and 4. There are 5 levels. So in this create new transform, I will add a recode condition. I will select a variable, and that variable is the last one. Okay, it is already there. No. So again, then what? I'll have to delete this or what to tell them. Okay. So I have to edit this. So I have used a new transformation. So you can see here, I will write this This is the same variable which I am using. So here, if you have to see that if equal to like 0, I will create one category for 0 and for rest of all another category. So I will select this equal to from here, this, and equal to is 0, then I will use it as a 0. Else, I will use it as 1. It has just a sec. It's a second. Else, use 1. And now you can see here, it is there. 0 and 1. So what is 0 here? 0 is the no this proliferation or no complication, and 1 is it has clubbed all these three, all the four category. Okay. Similarly, I'll create the transformation. I'm transforming these variable. So this is my first transform variable, and similarly I'll create the another transform. So I have done it already in the another sheet, and we can see that. So this is the, you can see like this is 1 and 0. If you see this is another category, and if you see this transform, then this is again, I have created like less than equal to 1 as a one category, and then if it is more than 1, then it is that means if it is anything else than that, then I will use this category. So this is another category. So similarly, what I am doing here, I am clubbing these category. I am creating a binary variable. It's a dummy variable, which is like clubbing the categories together. How it is doing? That same article. If you see this article, and if I go here, so I'm how I'm doing it. I'm taking this in one, this as 0, and rest all these as 1. One category this. In the other category, what I'm doing, I'm clubbing these two together and these three together. Right. Then in another one, how I'm doing it, I'm clubbing these three together and these two together. And then in the next one, I'm clubbing these 4 together and this together, this as a separate one. Okay. This is how I have created 4 dummy variable. Am I making sense to all of you? And this is done using the option of transform, which we have seen here. The transform, you can create another transform, and there's a beauty of transformation that you can, like if I use another transform. So you can write here the variable, and you can create a new, select or create new transformation. And then again, you can give that same, which we have just seen, less than equal to 2 and more than equal to 2, and similar thing you can do. So this was regarding creating these many variables. Again, this is a little, you can say that you have to do this action for like 3-4 times, and you have to run the binomial logistic now at each level. So we will do this here. So what I will do, I will first delete all this analysis. Otherwise, all. So now these are my 4 variables. And then what I'll do, I'll go to this regression. And now I will perform what I'm doing. I'm checking the assumption of this proportional odds. So I will go with this binomial. And in binomial, I'll do 4 binomial. So first I will use this dummy variable 1. And I'm just showing you with, let's say, gender as a factor. And let's say with these two. Diabetes duration here. HB1C here. Hypertension in this case. Age as a continuous. So all ordinal variable and the this nominal variable in this box. So it will give you the this odds ratio. You have to go here, And from this model coefficient, you have to click on the odds. So this is your odds ratio. So this is odds ratio of what? Like no diabetes retinopathy versus all category together. Now I'll duplicate this result. Why? Because I need to compare the odds ratio, which Dr. Sumana was asking. Like I am now taking out the odds ratio for each level. So I will just duplicate this analysis duplicate. And then what I'll do, instead of this dummy variable 1, I'll move this dummy variable 2. And then we'll see the odds ratio. Again, I'm not interpreting it. I'm just right now performing the analysis. I will duplicate this. Why I'm duplicating every time? Because otherwise the result, output is dynamic here. If you move this variable back and if you don't duplicate, then there will be a problem that you cannot see that. So that's why this is the binomial logistic regression for dummy variable 3. Dummy variable 3 is what? This one. 3 is when I have clubbed this 1, 2 and 3 together and severe and proliferative together. Then again I will duplicate the result and I'll move this dummy variable 3 here and 4 in this case. So now I have got 4 model coefficients, right? So I'll start seeing this. So what is the value here in case? So right now I'm just taking this gender. So what is the odds ratio? Let's start from the beginning. So there are 4, So I'll see first this dummy variable 1. So what is the odds ratio of gender? This male taking female as a reference. What is the odds ratio? It is 1.54. Right. I'm only focusing right now on this. Means odds ratio of gender. Coming to another dummy variable, what is the odds ratio here? It is, what is the odds ratio of gender here? Yes, all of you please write in the chat box. Increase, but yeah, true. It is not the same. It is 1.72. If I come in the third, what is here? 1.70. Okay. So if you see these 3, can you say that yes, it is nearly same odds ratio up till third. If you see this fourth one, what can you see? In the fourth, where there was a severe and all other category clubbed together, 7.28. So it is very high. So can you say, seeing this, that the assumption of proportional odds is met for gender? For all level. For 3, it is okay. First, second, third, it is there. But for fourth, it is not there. Do you agree with me?
Yes, ma'am.
Now, if you see the for age is below down. So what is the value? This 1.04. So for age, you people also write down in the chat box. Why? Because it will be easy to see the value. So age is 1.04. If you see the dummy, what is age? What is the odds ratio here? Yes, all of you please write in the chat. Or say, yeah, 1.05. What is the odds ratio here?
1.05.
Okay. And what is the odds ratio in the fourth one? 1.1. But can you say that, yes, it is almost met 1.05 and 1.1? Nearly same. That's, remember second example, where we can say that the proportional odds is nearly same. Yes, Dr. Arun, you raised your hand.
Ma'am, in this uh, the fourth model, इसमें ma'am, the thing is that how will we interpret this, ma'am? Like that is ये जो first four सब categories थी ma'am, उनको हमने club किया था versus the severe one. So our understanding would be that, ma'am, that the odds of developing severe diabetic retinopathy versus the other four categories as the age increases by 1 unit is 1.1 uh, or 10% more than uh,
Yes.
vis-a-vis severe versus the other four.
This is the fourth one is this one. I'll show. Actually, this is proliferative, na?
Yes,
Yes.
So
ma'am.
this
Yes,
is
ma'am.
proliferative versus rest.
So with 1 unit increase, ma'am, with 1 unit increase in age or 1 year increase in age, there is a 10% more probability of developing proliferative diabetic retinopathy versus the others.
Yeah. Odds more or 10% increase in odds as compared to the rest all clubbed together. Yes, that's how. But again, this is not the proportional ordinal. This is not the result of ordinal logistic. Are you getting my point?
Yes, ma'am.
What I am doing now?
Is binomial logistic.
Assumption.
Assumption.
Yes, ma'am. Assumption check करें ma'am.
It is assumption. This you don't have to write. Write means the result of these binomial logistic. You don't have
Ma'am,
to write it in the.
but since we created a dummy variable, ma'am, and in dummy variable, ma'am, we had clubbed the first four categories on one side and the proliferative in one side, and then when we clubbed the predictors and got the result of a model, and the result of the model was 1.10, then the interpretation that we made just now, ma'am, is it
Yeah.
correct interpretation, ma'am?
Yeah, it is okay.
अगर binomial ही plan है तो करना.
And anyone else, any other question? Like what Dr. Arun is saying, interpretation is perfectly fine.
अगर ordinal नहीं करना है तो.
Yeah, Arif Unhera, yeah, you want to say something?
Why do we need to club the categories? Can't we just have dummy tables for each category separately? Like for first one, 0 will be for the no diabetes retinopathy, and 1 will be for the rest. And for the second one, like 0 will be for the second mild DR, and the rest will be 1.
So you want to say that you want to say this, that you only want the second category. First one is okay, but second one between this and the rest.
Yes, ma'am. Like the rest means, yeah, yes, ma'am.
Rest or this only the mild or wo, only the mild versus moderate.
नहीं mild और risk कह रही है.
No, ma'am. The mild versus all the rest.
So no, but you cannot leave this. Why? Because this proportional odds, if you see it, it tells you the increment. Increment means the assumption is whatever with that software package it was there, it is there. It takes both these category. That's why it is known as a cumulative. We have not told you the concept of cumulative odds. If you wish, I may tell this on Monday. We have deliberately deleted that slide because generally that creates confusion in the participant. But I think if you have asked this question, so it's basically the cumulative odd. So it's these two together and these three together. Then again, if you make another category, we have to take cumulative, these three and these two. So we cannot leave the other one, the first one.
Yes, ma'am. Ma'am, will you share a few more information on the cumulative odd later on?
Sure. I will demonstrate here. I will demonstrate. I mean, just in the morning, we deleted that slide. I mean, I can tell right now also because it's there in the, but for that, I think that's a concept which I guess maybe not everyone will like to know. But again, I will tell. Don't worry. The concept of cumulative odd, I will tell you, but right now you just understand that you can't leave this category without finding. You can't like only take this mild versus rest. Is that okay?
Yes, ma'am. Yes, ma'am.
If that is there, then you need to create another variable. You can do that if you wish that. But then you have to run a binomial logistic where you will only take this. How you will do that? You will convert this as one, and then you will convert this whole as one, and you will leave this. Or you can make this as a missing case. And then you can still do that. There's no problem. But again, this will not be very much applicable because you cannot, in all these patients, basically, you cannot leave this people who are without findings. Why? Because ultimately they are also your population. So whenever you make your model, you can't leave this, this population. So that's why I think there is a concept of cumulative odd, and we will discuss this on Monday. Is that okay with you? Dr. Arifun Nehra? I
Ma'am?
think, yeah.
मैम once मैम this concept आपने explain कर दिया, उसके बाद मैम लास्ट में मैम प्लीज एक बार दोबारा डमी वेरिएबल कैसे क्रिएट किया था वो प्लीज आप डेमोन्स्ट्रेट कर देंगे बाद में मैम.
हाँ हाँ, अभी मैं कर दूंगी. एक बार ये देख लेते हैं. डमी वेरिएबल के लिए वही है, क्रिएट ट्रांसफॉर्म करके मैं उसको करके बता दूंगी आपको.
जी मैम थैंक यू.
उसी तरह से आप बाकी वेरिएबल भी देख सकते हैं. जैसे आप लाइक यू कैन सी अदर odds ratio also, right? So there is another option of testing this using a parallel line, but for that we need another module to install. I am not telling you right now. So for now, let's see. Although the assumption of proportional odds, if you see this individually, it is met for age. Yes, if I see the variable, and if you see the other, I will show with another example also. One more example. So this was my dummy variable 1. So let's say HB1AC. Oh no, let's take hypertension because there are two. So hypertension is 2.23 in case of a first dummy variable. If I go down, so in case of a dummy variable 2, what is the hypertension? 2.25. In case and it is 2.23. Same. If I go down, it is 3.42. Again, it is not met. And if you go down, it is 2.84. So it is nearly same. So you can, by seeing these value, we now assume, let's say that the proportional odds assumption is met. Okay. Although it is, you have to see, like initially we were discussing, Dr. Venkatesh, probably he has said that if the concept of proportional odds, you have to check it variable wise. For all it is a variable, and you can only include those variable in the model where this assumption was met. So for us, it is meeting the assumption with age, let's say hypertension, and let's say for right now it is there with all. So now how will I do that? The ordinal logistic. So I will go to the regression. I will click on this ordinal outcome. And now I will put this disease, this diabetes retinopathy in the dependent variable, and this gender here as a factor, age here, the duration here, HB1AC here, and hypertension. So if you see, again, you come to this model builder, all are there, reference level, the same as we have learnt in logistic. Female 0 to 5 year, HB1 is less than 7 is the reference, model fit, it gives you the overall model fit you can click, and for model coefficient you have to click the odds ratio. So this you can see that this gives you only single table. Okay. This doesn't give you. I will run multinomial also on the same data set. Then you see how that appears. So this is your output. You can see the model, the value, p value, it is significant, less than 0.001. If you see this is male and this is gender. So gender, the p odds ratio, I don't need this log odds upper and lower. This is giving you the estimate 95% confidence interval. I need the odds ratio. So I'm not clicking right now the confidence interval, because then again there will be a horizontal extension of the table. So just for interpretation, if you see, now it says the interpretation 2.15. So I can say that at each at every level, the odds of falling into the higher category means the way we have learned proliferative. That's how they write. That's how we have to write. We don't have to write each and every category. We just write that the odds of falling into the higher category is 2.15 times more in male as compared to the female. For age also, we will again say the same thing. For every additional increase in age, the odds of falling into the higher category of this diabetic retinopathy severity is 1.06 time, or 6% higher odds of falling into the uh, you know into the more severe category or into the higher category as every 1 year increase. If you see these duration, this thing, it takes 0 to 5 year as a reference, and that's how it is writing all these as 0 to 5 year. And then you can say same thing, like odds of falling into the higher category is 3.78 times more if the duration is 5 to 10 years. Similarly, it is 8.21 times more in people who are having a diabetes mellitus for 20 to 25 years. If you see this hemoglobin HbA1c level, it is less than 7% is the reference level here. So what do I mean by 1.52? So I will say that odds of falling into the higher category is 1.52 times more for people who are having a HbA1c level 7 to 8.5% as compared to less than 7%. Similarly, hypertension, I may say that odds of falling into the higher category is 2.43 times more in the people who are hypertensive as compared to non-hypertensive. So this is, but again, this I have told you for PG thesis and all we say, but generally if you see the interpretation, we don't write. If you see the article, I'll just show. Result. See, they have just written the result of the multivariable ordinal logistic regression are presented in table 2. All variables except age retained their statistical significant association with the severity. That means the concept of proportional odds, it was met, and that's how they have written. They have not written like all these, but again, you should know, maybe in the discussion they have written something. But very briefly they have written. But again, you can write, you should know how the interpretation is done. And then again, this was the proportional odds. Now again, since in this case, my proportional odds assumption is not met. So what will I do? I will go and I'll perform a multinomial. So I will go and I will select this multinomial. So in case of multinomial, yes, Dr. Rudresh?
Ma'am, I had this query that, ideally, they should not have performed ordinal regression in this case. Like, they should have done multinomial regression because the assumptions were not met in the
Actually,
paper.
no, but we don't know. This data set is not of that paper. This too we have created.
Okay, thank you.
This is not their
But
data.
Okay,
They
but assumption for each odds ratio must be fulfilled before doing the ordinal,
are, yes,
ideally.
yes, and there's
Thank
a,
you.
again, generally we do it with the concept of testing parallel line, which I'm not telling you. I'll tell you. Right now today I'm not telling you. I have adopted this longer route. Longer route means creating dummy variable and testing each binary logistic. Why? Because to make you people understand the concept of cumulative odds, because you club the category, okay? Otherwise, in that case, you would not have understood how the these statistical package, these run these tests in the background, okay? Yes, Dr. Arun.
Ma'am, इसमें what I understood was that when we are interpreting our result and the table that we finally got, so it is proliferative diabetic retinopathy on one side, and we are finding the odds for all the predictor variables, ma'am, of developing a proliferative diabetic
No,
retinopathy.
no, no,
Is
no,
it?
no, 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 no. Coming. Actually, वो slide, that slide probably will make that slide. This is the odds. See, I will tell you. Let's take one odds from their result. Or let's say we will take from our result only. If you take this 7.28,
नहीं जो बाइनोमियल क्यों ले रहे हैं?
just a sec, okay. Binomial, like I wanted to,
क्यों बाइनोमियल ले रहा है?
this, एक minute रुको.
2.15.
This is like 2.1. Can you see this 2.15? This odds?
Yes, ma'am.
No, sir, my
Now I will go to this category. So what do I mean by 2.15? So I will say that the odds of falling into the higher category means this odds is same. So across how many categories? Without finding and all these together, mild, moderate, and severe. Then these two and all these three together. So ultimately, how do we write that odds of falling into the higher category? So any person, if the female is like this was for the male now. So if the male is in without finding, so odds of going into the mild, obviously he will not go directly into the proliferative. Are you? Because it's a cumulative thing. So first he will go to the proliferative. So odds of going into the mild means higher category if the person is in without finding. If the person is in this stage, because this is predicting everything, if the person is in mild non-proliferative, definitely he will go to the moderate. So falling a male into this moderate category is 2.15 times more than the female. If the person is in moderate, then he will go to severe, the higher category, 2.15 times more in male as compared to female. And if person is already severe, then he will, just a sec. If the person is in severe, then the odds of going into the proliferative for a male, it is again 2.15 times. Have you understood or not?
इसलिए proportion not से
Ma'am, you now understood, ma'am.
That's why I said that in multinomial, you will have 4 odds ratio. Why? Right now, I'll show you. It will compare all these. Taking without finding, it will give you odds of without finding too mild, without finding too moderate, without finding too severe, and without finding too proliferative. Are you getting my point? There, a person, you can tell the odds of person without finding directly going to the proliferative. But in this case, you cannot tell that because it will predict the next higher.
Yes, ma'am. Understood. क्योंकि वो हमने proportionality maintain रहेगी, ma'am.
हाँ, इसलिए एक ही ऑड्स रेशियो है, इसलिए इसमें उतने सारे ऑड्स रेशियो नहीं है. ये यही अज्यूम करता है कि नेक्स्ट लेवल जाने के लिए जो आपका है प्रोपोर्शनल ऑड्स अजम्पशन, वो जो लेवल है वो जो वैल्यू है,
Maintained.
ऑड्स अगर चेंज भी हो रहा है, जो हमने देखा था शुरू की स्लाइड्स में, वो रेशियो मेंटेन्ड है एट ईच हायर नेक्स्ट हायर लेवल.
It should.
मतलब अगर प्रोपोर्शनल ऑड्स अजम्पशन मेट है तो.
राइट मैम समझ आ गया मैम.
ओके. एनीवन? एक्चुअली इसको हम लोगों ने सोचा था कि इसको स्लाइड में करके देंगे, बट वी कुड नॉट मेक इट इन द स्लाइड. दैट्स व्हाई आई हैव टू कम बैक टू द आर्टिकल, बट दैट्स ओके. इफ यू हैव अंडरस्टूड, our purpose is served. Now I'll show you the multinomial in the same this thing. So multinomial is this severity as a dependent variable, and hypertension here, gender, age, so now you can see how many models. So you will see that it gives you, so it gives one this thing. If you take it is taking female as a reference, so let's make it as a, yes, that was same. So it will give you odds of, see the first odd, if I take the example of the gender, then 0.957 is the odds of a male falling into a mild as taking no. Okay, this is okay. But again, it gives you moderate versus no, another odds ratio, which is, okay, this is not odds. I'm sorry, this is p-value. 1 minute, let me click the model coefficient. It is the odds ratio. I'm sorry. So this is 1.47, this 1.04. This is the odds ratio. This 1.45 is the odds ratio of moderate versus no. Can you see here the reference category is maintained? It is not the next higher. If you come down, it is the severe versus no. And the gender has got 0.92. It is not same because it is changing. If you come down, it is the proliferative versus no, and the gender has got 7.88.
मैम इसमें आपने डमी वेरिएबल को यूज नहीं किया ना डिपेंडेंट वेरिएबल में डालने के लिए?
नहीं, बिल्कुल नहीं. जो ओरिजिनल वेरिएबल है, अगर आप
हाँ.
देखें, डमी वेरिएबल अभी मैंने बताया है आपको, लेकिन एक और ऑप्शन मैं बताऊंगी जिसमें आपको डमी वेरिएबल क्रिएट नहीं करना पड़ेगा. वो एक टेस्ट ऑफ पैरेलल लाइन का ऑप्शन होता है. वो आप क्लिक करेंगे तो वो आपको सिग्निफिकेंस लेवल बताता है, और आप उसको देख के समझ सकते हैं कि किसका अजम्पशन मेट हुआ और किसका नहीं. बट वो अभी
ये
हम बता रहे हैं.
मैम ये बेसिकली हमने जो डिपेंडेंट में डाला है वो हमारा जो ओरिजिनल डेटा फाइल था उसी से इसने उठाया उसको, और अकॉर्डिंग टू दैट जो लोएस्ट वैल्यू था उसको रेफरेंस बना के इसने बाकी सबके साथ कंपेयर किया है. ऐसे ही है मैम?
Yes, yes. Reference you can change also. Like yesterday you said, na, you want to
Yes,
compare free, frail and frail. So you can change your reference
यस
level.
मैम. जी मैम समझ गया मैम. मैम
Okay.
ये जो पैरेलल अजम्पशन का था मैम, आपकी एक वीडियो थी उसमें बाई स्क्वायर में भी आपने एक्सप्लेन किया था वो शायद, if I'm not mistaken.
Can you repeat? Can you repeat once again?
मैम the one that you're explaining right now about that पैरेलल assumptions चेक करने के लिए, वो आई थिंक आपकी बाई स्क्वायर की वीडियो थी मैम आपकी, उसमें मैंने पढ़ा था मैम, उसमें भी आप शायद एक्सप्लेन कर रहे थे उसको.
एक्चुअली वो ना SPSS में है, लेकिन इसमें हम लोगों ने अभी नहीं बताया. इसमें हम लोग बताएंगे. जनरलाइज लीनियर मॉडल एक ऑप्शन है, उसमें आप इसको टेस्ट कर सकते हैं, लेकिन हम लोग अभी स्टेप वाइज जा रहे हैं. ठीक है, तो इसलिए अभी वो आज नहीं बता रहे हैं. वी आर नॉट टेलिंग दैट टेस्ट ऑफ पैरेलल लाइन टुडे. We are just telling you by creation of dummy variable. Okay, if you learn this, then we'll tell that. Otherwise you will not learn this. Like progressive, which you learned now, you would not have learned that if I would have directly gone to that option. See, once you are going stepwise, then only you will understand. Dr. SV is writing, if assumption of proportional odds is not met, then does it make sense to use multinomial?
Multinomial
Yes,
regression
yes.
नहीं चाहिए.
You have to use multinomial because there is no other option. Other options means you have, like we have told now, that you can run binomial also. You can club the do two, like in this case, if the concept of proportional odds was not met, you have got three options. First, you can run multinomial. Second, you can treat these ordinal nature as a continuous and you can run linear regression. And next, you can run a binomial and you can club these category together, like without proliferative and all complications together. And you can run a binomial also. It is up to you. If you want to show the various different, if you want to show various levels and different odds ratio for each level, the best is you should use multinomial. Okay.
Ma'am, the example which you showed, you should take the p-value before comparing the odds or directly go for the odds.
Which one can you please guide me?
No, the same example. So the p-value is almost like it is not significant in almost all of the parameters. Then should we, I mean, probably the data might be jumbled
P-value of what you are telling?
for each like age,
Variable.
for each other, if you go up, it's like 0.45, 0.67, 0.728, 0.89, 0.957. So it's almost not
Okay.
significant. So do we actually have to take it, or we can just delete it, or just like that, leave up this p-value, look only to the odds?
No. That initial concept which we have learned, like making the model here also, you will do the similar way. You will only put in multinomial. We have learned yesterday that you run. Let me do it again. Here again, I will go with for unadjusted. So I'll put gender and see. So gender, if it is not significant, if you see the p-value, so it is not significant. So then I might not take this into my model if it is not. So in here also you give the unadjusted and adjusted. That is here. I mean, that is there. That is not like here I cannot take everything and just report the odds ratio without p-value. No, I don't have to do that. Significance.
I'm just asking, ma'am, if the same data is the same from what the paper is, or if this is a data which you have created?
No, that's what I said. This is the dummy data. This is not from the paper.
Fine. I understand. Thank
Okay, that's why maybe don't confuse that what the author have written and what.
exactly. Because in that, that's it, like age is not, so it's an association factor, but it is not statistically significant according to the paper. So here it is, data is a little bit confused. So I got confused. Okay, thank you.
Okay, so it is for all of you. It is a dummy data because getting data we did not ask, and why? Because we made that paper as a reference. We did not tweak the data to make the result exactly like that. We have just created a dummy data, taking all those same variables, and just we are showing the process. So don't compare the result of the paper and the result here. Okay, so if it is okay to all of you, can we move to the breakout room and practice this? Okay, no, and
Transformation.
okay, yes. I'll show that. So I'll do that in, let me delete this, okay. So I've deleted these 4 columns. Now I'll create the data, this thing, transformation. So go to this transform. And here my source variable is severity. Now I have to, here you have to write like dr1, dr dummy _1. then you have to select. So wherever you have to create transformation, you have to select the source variable. So if you click your cursor here and then create this transformation or write the transform, click the option of transform variable, you have to name the option here, the transformation of variable. Source variable is this. Now you have to use, although there are other rules which we have fixed, but I am using create new transform. So the name is transform 5. You can change this as a transform dummy 1 or transform dummy 1. And then there is an option like add recode condition. If I press this, add recode condition, and I have to select the source. And since the source is already, I know because I have I have selected that variable. So I will go to this option of equal to. So I will use this 0, and then because 0 is without any complications. So I am using this as 0, and the rest, everything I am clubbing it together to give it as 1. So rest I am writing as 1 and then press enter. So this is my
नोट डी आर रेस्ट भी कर सकती हैं,
this one.
दिखाने के लिए नोट डी आर रेस्ट.
Similarly, now if what you are saying?
You can write also node dr rest करके.
Okay. So yes, Dr. Shamshad is saying that if you don't want 0 and 1, what you can do instead of 0, but if you are writing it in words, you have to put it in single bracket. So you can write like no diabetic retinopathy, no DR. I'll put it in, and then you have to put it in single bracket. Else you have to write in the single this thing DR.
Nearest others.
DR or others. Okay, others I am writing, or you can write others. Then what? Okay, name else use. This has not taken. Just a sec. I will again go. No DR. Else use. If you don't press enter, it will not take. So I am forgetting. I am pressing enter. So can you see now? Initially it was taking it as 1 and 0. Now it is taking the name. So use whatever you write here. If you write 0 here, it will show 0. If you write 1 here, it will show 1. But if you are writing in the name, then you have to put it in single, this thing, inverted comma, you can see. Otherwise, it will not take. So this is how we create. This was 1. Again, if I have to create another dummy variable, then again I have to go here. You can use again the same, there is a transformation rule. So again I'll go to this transform. This is there. So this is the second dummy. So change the name otherwise. Here dummy 2. And I have to create new transform. And I'll write transform dummy 2. Again, I have to add recode condition. So here now I will take both 0 and 1 together. So I will write if it is less than equal to, if it is less than equal to 1, less than equal to 1, I will use here now, but here now you will have to give like mild, because that no and mild you have to club it and give a name. So it's better that you write 0. So 0 for this, else use 1 and then press enter. So this is another category. It should have been here. I don't know. Then I'll create another transform. Again, you have to go here. Sorry, this, I'm deleting this. Transform. This is my dummy 3. dummy 3. And here I have to take 0, 1 and 2 together. So I will again select here, create new transform, dummy 3, dummy 3, add recode condition. If the source variable now I have to use less than equal to 2. So less than equal to 2, I will use as 0 and rest as 1. Press enter. Then this is another dummy variable. Okay, so this is how, here I have shown you both the ways. If you want to write it, you can write it, but you have to put it like in the inverted comma, single inverted. Else, here write 1 and 0. Why? Because it is difficult to give the name of all these club variable. So on the basis of that, you can create these many dummy variables and you can create so many binary logistic the way we have seen. So please go to the breakout room and practice.